Hey guys, Dr. Brown here with Kubo Math coming to you from Tarlac City, Philippines. And tonight we have integration of trig functions. And we'll mostly be using U sub. And we only have 5 problems, so maybe 10 or 12 minutes. So let's hang in there and let's get busy. Okay, we have the integral of pi sine pi x dx. Okay. Let's let u equal pi x. du then will equal pi dx. So if we isolate dx, we have du divided by pi equals dx. Okay? Alright, let's sub some things in here. Now we have pi, which is a constant, times sine u. Remember, u was pi x, so sine u. But now we need to replace dx because we're going into the u world here. So dx is replaced with du over pi. Hey, the pi's cancel. We end up with the integral of sine u du. Well, you know the derivative of sine is cosine, so the integral is minus cosine u. And that equals minus cosine pi x plus c. Okay, that would be our first one. Not so bad. All right, this one we have the integral of secant squared x over 2 dx. Now I've noted the integral here of secant squared x equals minus cotangent x. In the coming days we'll have a video on how you take the derivative of minus cotangent x to get cosecant squared x. So we'll do that with the limit, just to show you in the spirit of, well, where did they get that formula? So there's several videos we have out now dealing with where did they get the formula, because now that I'm retired I have a little time to try to noodle around on some things. Okay, in this case, let's let u equal x over 2. Okay, so what is that? That's 1/2 x. So du equals 1/2 dx. So if we divide both sides by 1/2, we have du divided by 1/2, so now it's du over 1 divided by 1/2. Invert the 1/2 and multiply, we have 2 du equals dx. Okay, so now what do we have here? We have cosecant squared u, and we're replacing dx with 2 du. Okay, so the integral of the 2 comes to the outside. Let's do that. Cosecant squared u du, and that equals minus cotangent u. So we'd have 2 or minus 2 cotangent u. So minus 2 cotangent of u, which was x over 2 plus c. So you can see that there are certain things we just have to remember sometimes. And in calculus there are quite a number of identities, the derivatives of various things. As a matter of fact, if you've ever seen a book of integrals, it's about that thick. I have one back in the US. It's amazing the integrals that are in it, and it's also amazing if you can study up on that you can just flip through and find the answer to some major problems. Okay? All right, so we have 2 down. Hopefully everyone's studying. That's important. All right, what do we have next? We have the integral of x sine x squared dx. Well, immediately you could see if we were to allow u to be x squared, what's du? 2x. And if we isolate then the dx, we would have something that will divide out the x. So let's try that. U equals x squared. Du equals, bring the 2 down, x to the 2 minus 1, which is 1. And then the chain rule, the derivative of x, which is dx. So now let's isolate the dx. So I'm going to divide both sides by 2x. Du divided by 2x. So if I divide that by 2x, the 2x's cancel, leaves me dx. So now then, let's just plug all this in. We have x times sine u, and we're replacing dx with du over 2x. X's cancel. I'm going to bring the 1/2 to the outside. I have 1/2 times the integral of sine u du. So 1/2, derivative of sine is cosine, so the integral is minus cosine u. So minus 1/2 cosine of x squared plus c. Okay, I do have the answers over there where you can't see them, just so I can check myself to make certain. Okay, let me check that one off so I don't repeat them. All right, this one's interesting. Sine 2x times cosine 2x dx. Well, sine and cosine are friends. They like each other. So when you see them together, that's a good thing. What if, though, we let u be sine 2x? Its derivative would fall in line with that. There'd be a few other things going with it, but still, that might just work out. So u equals sine 2x. du is cosine 2x. So we took the derivative of all of that. Now we need to look on the inside. Now it's derivative of 2x, which is 2 dx. So let me rewrite that. That's 2 cosine 2x dx. So if I isolate dx, divide both sides by 2 cosine 2x equals dx. Now then, what do we have? We have the integral of u times cosine 2x, and we're replacing dx with du over 2 cosine 2x. You can see this cancels with that. I'm going to bring the 1/2 to the outside, u du. So that's du to the first. I'm going to increase that by 1, divide by it. So now I have 1/2 times 1/2 gives me 1/4 u squared. Okay, so that's 1/4 u, which is sine 2x, and that is squared, sine squared, because it's u, which is sine 2x squared, plus c. 1/4 sine squared 2x plus c. Okay. We are rolling, knock on wood. Hey, buy a kid a book, okay? Get connected with your local school and help some of these kids. I know here in the Philippines, many schools don't have books for their children, and they utilize PowerPoint presentations. The kids get the file, they have to go print that. That's a cost to them. Yeah, we can just do better. I don't know what I would have done in school if I didn't have books to study from. I mean, even now, I still have a lot of my books from late high school and college, especially college. I didn't sell any of them back. Maybe an English book or two, sorry. But I kept all the math, science, engineering related books, all of them. and I use them as references today. I'm 64. I still do that. So I can't imagine what my career would have been like if I didn't have books. So buy a kid a book. Get connected with your local school, and let's help these kids, okay? All right, this one, last one. Cosecant squared x divided by cotangent cubed x dx. Whoa, this one's crazy. Okay, if I take, well, we know cosecant is 1 over sine. So I have 1 over sine squared x. 1 over sine squared x divided by, and we know tangent is sine over cosine. Cotangent is cosine over sine. So I have cosine cubed x divided by sine cubed x. And that integral sign, I'll make it bigger. And we're integrating that with respect to x. So you can see if I flip this fraction up, I'll do that here so we don't run out of space. We end up with sine cubed x over sine squared x. So I'm flipping this up, times cosine cubed x. So what happens here? Well, this 3 and that one, they cancel each other out, except I'm left with sine x in the numerator because I have 3 of them here, 2 of them there, divided by cosine cubed, that's with dx, cubed x dx. Okay, we haven't integrated yet. We've just gotten it to a different form and reduced it from this to that. Okay, now then, if we were, remember sine and cosine, they're big buddies. What if we let u equal cosine x? So du equals, derivative of cosine is minus sine x. Okay, dx. Oop, chain rule. Now let's divide both sides by negative sine x. So du divided by negative sine x equals dx. All right, so what does that give me? I have the integral of sine x divided by u cubed, and now we've introduced the du divided by negative sine x. Well, sine x cancel. I'm left with a negative, the integral of u to the minus 3 du. So the negative is here. Brought that up to the numerator, so that made that a negative 3. Now then, let's integrate. So let's add 1 to that and divide by it. So negative 3 plus 1 gives me a negative 2. The negatives cancel, so I end up with 1/2. Got to keep this 2 that we introduced here. So 1/2 u to the negative 2, or 1/2 over u squared. Well, what was u? Cosine x. So we have 1/2 over cosine, and it's u squared, cosine squared x. So that's 1/2. What is 1 over cosine squared? Well, it's secant squared. So I have 1/2 secant squared x. All right, so, plus c. Man, we almost lost a point there in school. 1/2 secant squared x plus c. That is use of u sub dealing with trig functions. So understanding sine, cosine, tangent, but also understanding cosecant, secant, cotangent, and how those interact, and then some derivatives of some of those, or integral of, like we did earlier. So lots of things to remember, but the way you understand them is practice. Practice, practice, practice. Okay, buy a kid a book. Why are we doing all of this now? We're trying to build a better tomorrow and do that through math. Okay? All right, we're getting there, guys. Appreciate the feedback from folks, and we really appreciate you. Let's keep moving forward and study, study, study. Okay, that's all for now, and we'll talk to you next time. Thanks.